And today on a bench we have a Yaesu FT-840. Not a model you see a lot of, but a good radio. Actually shares a lot of similarities to other models from Yaesu. And yes, there's yet another Yaesu on the bench. That one's actually done. I'm just letting that one sit over there. Probably that video will probably get uploaded before this one from a different customer. I had to do an alignment on that one. This one actually has a problem. That one was just horribly off frequency. This one, customer says, seems like cold solder joints or plug. Powers up fine. Sometime receive cuts in half. Also affects meter reading. Also no output on transmit. Will return with a tap to the top. Sometimes will factory reset and lose memory. New battery installed last year. Need to fix and realign. Checkup. So haven't powered it up yet, and quite honestly, not going to. It's an older radio. Probably most definitely has some bad solder joints, or bad intermittent connections. So what I want to do is just pull the circuit boards up. Now I don't need to unplug everything. I just need to get the boards up. I'll have to unplug a few connectors to be able to get the boards up, but I want to inspect the bottoms of all the circuit boards. It's not super simple, but it's not very complicated like some transceivers. You get some radios where the circuit boards can be 3 deep. They're stacked on top of each other. True nightmare to take apart. This one's fairly easy. Board on this side. Board on this side. Now this one's more complicated to get out than this one, but I'm going to take this one out anyhow. Now someone has already fixed a known problem with this radio, and like I say, a few other versions that Yaesu made, and that's the Chernobyl resistor. So as you can see, there's a big ceramic resistor sticking over here on the side. Okay, now actually I'd like to see a little bit of thermal glue gluing that to the cabinet so it can more efficiently transfer the heat into the sheet metal, but that alone is fine probably. But I want to take this board out because whoever did that repair by removing the resistor and putting a much higher wattage one, moving it over here, well, when they had the board out to solder these wires on, they didn't change the electrolytic capacitors. You see the color of those electrolytic caps right there? They're supposed to be yellow. Kind of a goldish yellow color like these. They're black. That one's black, that one's black, that one's black. And all these other ones in this immediate area have just been heat soaked. So it's a preventive maintenance thing. I'm not going to recap the whole radio, but those really need to be changed. I can pretty much guarantee you those 3 filter caps right there, they're either way off or open, or yeah, they've just drastically changed in value. So I'll get that pulled out. Actually, it's not that bad getting this board up. You just take the rear, man, I just did that in, God, I can't remember what model radio that was. I just did one here not too long ago. But I showed how to do that in that video. You just take off the rear panel because these jacks kind of stick out the back through here. So the only way to get this board up is take these 2 screws out, the sheet metal falls off the back. Unplug the 2 Tmp connector coax cables right here, and then you can just fold the board up, okay, and that allows you access to the underside fairly easy. Now there's 2 regulators down underneath there. They plug in to this plug right here. So trying to get this board, when you reassemble this, back down and plugged into that header socket there is a little bit tricky. So what I do is, once I get this out, I'll take those 2 screws out, remove those 2 regulator transistors, do what I want to do to the board, but when I go to put it back together, what I do is I plug that little daughter board that is underneath here that has those 2 transistors attached to it, or those 2 regulators attached to it. I plug them into this socket and then fold it down. Once I have this board screwed down, then I put the 2 screws back in for those 2 transistors to attach them to the chassis. But yeah, trying to just fold this down and get them plugged into those pins, good luck, people. So Yeah, I'm just going to say it's probably bad. It's obviously bad or intermittent connections because just tapping on the radio apparently brings it back. So instead of me sitting here for a half hour or an hour with the radio turned on, waiting for it to warm up and fail on me just to find out I'm going to have to pull the boards anyhow to fix a bad or intermittent connection or troubleshoot jiggling wires and whatnot, I'm just going to do that anyhow. This board needs to come out because those caps, these few caps have to be changed. They should have been done when somebody did this. And the main board on the other side, kind of like the other side's fairly easy to get out. We're already going to have the sheet metal off the back, so all these jacks, you don't have to worry about that. It's just a matter of unplug a couple cables and fold, take a few screws out, fold the board up. So let me get that, and once I get these boards pulled up, if I do find any bad connections, I'll fire the camera back up so you can actually see what I'm talking about. So let me get to it. Okay, so I've got the top board lifted up here. Like I say, just a couple cables to unhook and a couple wire ties to cut off to release this one so I could get the way it was kind of binding it up. And yeah, there's some bad solder joints on this. So basically what you want to look for is, it's not so much that you need to worry about components. Usually what's going to fail is anything that has any length to it. So a wire that has long leads, anything that can have stress on it. Jacks are a really good example of that, especially if those jacks come in contact with like the housing, so as parts are expanding and contracting, they could be putting a little bit of stress on the connector maybe, or in the case of this radio, it's common for like the external speaker jack for that to get intermittent because you've got a plug plugged in it and that can be putting stress on it. The Tmp connectors, always check those. So the connectors for all these little cables, you want to check the like in this case there's what, 4 I think, yeah, because there aren't any other ones. There's 4 Tmp connectors on here, so you want to check all these little guys. This circuit board, you can almost be guaranteed in anything, not just this radio, any old vintage electronics, if it has circuit boards standing straight up in the air, you're probably going to find some bad solder joints on that connection. And it's no different here. So if we flip the board up, hopefully these will actually show up. It's always so hard to tell looking through the viewfinder if it's visible or not because the viewfinder screen is so small. But that connection right there is absolutely making no connection whatsoever. It's no longer attached. Like I said, I don't know if I can get it at the right angle where you can see it, but the pin is completely broken out of the solder. If you look up here at, where are we at in the camera lens here? This one, again, it's cracked out. You can see a halo line right around here. If I can get the board turned to where you can see it. It just doesn't show up very good in the camera, at least what I'm seeing in the camera, the viewfinder. It doesn't look like it shows up very good, but you may be able to see that. But that one's, it's partially cracked out. At least I can see in the viewfinder. It looks like you can see a black line right there. Ooh, actually, if I hold this to shadow it a little bit, it really starts to show up. Like right there, you can really see the crack line. So that's what you want to look for. Best thing to do is, best practice is completely desolder it and then resolder it. Most people don't do that. They just grab their soldering iron, come in with some fresh solder and resolder it. The problem with that is this is old solder. All this solder on the outside is oxidized, anything that's exposed to air. When you have it where it's cracked, that means air and moisture can have gotten inside that crack. That's going to be, contaminated with, contaminants. Ideally, you should remove that solder before you resolder it. If you're not going to desolder it, I would highly recommend that you add some additional flux. That's probably the best piece of advice I can give there. Just put a little bit of extra flux on it, resolder it, and actually you can try this as an experiment. You can take a very, pardon my French, crappy looking solder connection. You can pick one, like that one right there. Come in with a soldering iron, come in with some solder. When you get done with it, it looks okay, but yeah, it's not very shiny and doesn't look very good. just squirt a little bit of flux on there and come back in and touch that with your soldering iron, and it'll be glass smooth. Nice, shiny, beautiful looking solder joint. Flux works wonders, folks. Be it in a gel form like this, liquid flux, whatever you're using. But for soldering brand new components together, yes, the amount of flux that's in a piece of flux core solder is enough. But when you're working on damaged solder joints and stuff that's old and may have a lot of oxidation on it, you really want to use some additional flux. The cleaning action of that flux is really needed when you're doing reflow work like this on old stuff. So let me go over this board, resolder everything I saw that's bad. A couple of these other jacks had some halos around them, and one of the Tmp connectors did have a halo around it. I'll get all these resoldered and go down to the board on the underside. I'll probably pull the PA module out. It's actually fairly easy to get out and try and see if I can take a look at it. But I'm suspecting probably pretty much all the problems are probably on these two boards, this upper and lower board. That's usually where the problems are on these, especially in this area where that Chernobyl resistor is. So I really, like I said, I want to change those caps, but I also want to inspect all of the surrounding solder joints, because as you probably saw, the circuit board was also very dark there. So you can pretty much be guaranteed a lot of solder joints around there are going to be really, really iffy. So I'll be back. Okay, so moving right along here. And I had noted there were some diodes that looked like may have been replaced on this board. Kind of the same with this. Looks like there may have been one or two diodes replaced. So I'm kind of wondering if maybe this, not a direct lightning strike, but may have had a high ESD event and took out a few components. But someone has definitely had both of these boards pulled out, at least, you know, to this point at some point, and resoldered some connections. And it's kind of the point here in this section is, if you're doing something, you've got a problem. External speaker jack doesn't work, or one of the data connectors, or something just doesn't work in your radio, and you have to pull it apart, and you find bad solder joints. Do yourself a favor, or if it's not your radio, it's a customer's, do your customer a favor and just resolder all of those type of connections, because they're all bound to fail eventually. And they will eventually. So I resoldered every single jack. All of the header connectors on the other side of this board have been resoldered on this board and on the other one. I resoldered almost everything in this area, because that's on the other side here, that's where that Chernobyl resistor used to be. So all of those look kind of horrible. The connections that go down to the voltage regulators, someone had already resoldered them, but it kind of looked so I went ahead and reflowed them again too. I have also done this IC. Now, some of the pins, you deal with a lot of surface mount stuff. You can kind of look at it and say, yeah, that looks fine. This one looks like there's just not quite enough solder on it. Like these three ICs, perfectly fine. This one, I just wasn't happy with the amount of solder they had on there, so I did reflow that IC. Big thing I noticed was, because remember, these are the two regulators. I think it's, what, a 9 and a 5 volt? 7805, yeah. So 7805 and a 7809. So these two voltage regulators plug in. There's the header pins. They plug into the header socket down here, okay? And then down to the heatsink, or a heatsink pad here, so it's heat sinks to the chassis. This may have been the problem here. Let me see here. Which one was it? These two pins. I'll probably have to put this down on the table so get the camera to focus on it. But if you look at those two pins, they are completely broken loose. I don't know if you can see that in the camera or not, but it's, yeah, they're not even attached. And all of them look bad. You can see those have huge halos around them. They're just about ready to break out. So, yeah, I'm going to, and honestly, a 7805, a 7809, they're a couple cents a piece. I'm just going to replace them on top of resoldering. I'm just going to desolder them and just put new ones in here. It's not going to cost the customer any extra in labor. I got to desolder them and resolder them anyhow, so I might as well just go ahead and chuck a couple cents worth of regulators in here, because these things have been hot. Because, you know, you can see here's all the gunk build up. Because remember, this is the bottom side of the radio. The Chernobyl resistor vented, you know, its heat would have come up through this hole here, cooking, and where does that heat directly flow onto? These two regulators. So now that that resistor, somebody relocated it over here, and yeah, you got to cut the wires off just the way they had this modification in here. But these things have just had a lot of heat on them over the years, so that's just maintenance. I'm just going to replace those. So only other thing I got to do, and actually now that I think about it, I probably resoldered a couple of those. I want to change those couple electrolytic capacitors because I have not done that yet. So yeah, I've already reflowed them, but yeah, I'll pull out these couple caps in this area, replace those, and if I remember, we'll test these. We'll stick these on a capacitor analyzer and actually see if they're any good or not. Just out of curiosity. Okay, so I've got the boards back in, replaced the electrolytic capacitors I had talked about and the 2 voltage regulators. The customer had said, you know, need fix and realign and check up. Well, I'm not going to realign this. I just checked it. There's absolutely no reason to do a transceiver alignment on this. It's transmitting on frequency. It receives just fine. So yeah, that'd be just a waste of a lot of money. So I am not going to do an alignment to it. And honestly, most amateur radios, unless something happened, a crystal drastically drifted off frequency or something, most amateur radios, they're good for several decades usually before you need an alignment done to them. They'll break. You'll have parts burning up in them long before they actually need an alignment done to them. So yeah, most solid state rigs, you really don't need to unless, yeah, something happens. Don't get me wrong, there's always the exception to the rule, but like I said, in the case of this one, it doesn't need it. That would just be a waste of the customer's money. I said I'd show the caps. I did test these already. Every single one of these, with the exception of this one, is bad. All of these caps are the ones that were in the power supply and audio amplifier circuit. So, of course, that's on the other side now. Actually, let's just turn the radio off. Get her unhooked here. So, all of those caps, these two, another one down there, which actually that's the one that was down back in there was okay, and then all of the electrolytic caps right here. And you can easily see what I was talking about when I said that's the color. Well, these are supposed to be blue, so it's not like they're the wrong color, but the rest of these, they should be that color. They're all varying shades of brown to black. As they all roll away from me here. They're all varying shades of brown to black. And most of these caps, or several of them I should say, they're open. They are no longer capacitors. They test in the picofarads. So when you have an aluminum electrolytic capacitor, basically one of these leads breaks loose from the inside or it corrodes off because the capacitors, especially in the case of these, they got cooked. So all the electrolyte has been vaporized in these poor things. The lead just corrodes off of the aluminum foil plates inside of it, and it just becomes disconnected. But there is still a tiny bit of capacitance, usually in the picofarads range, because you still have 2 wires that are parallel to each other, and there even may be some of the winding or of the foil still attached, but it's nowhere close to what it should be. So okay, now let's put her down on 15 volts because pretty much all of these are 16 volt caps. So this first one here is a 470 at 16 volts. Okay, there it is. Measures 166 microfarads. Remember, this is a 470 microfarad cap measuring only 167. What we're measuring now is leakage current. You see it says microamps right there. And it's dropping down. And that's normal for a large capacitor. It takes a little bit of time because these are current limited. The capacitor analyzer here is current limited, but it's it's slowly dropping down. So leakage isn't excessive, but the value is, yeah, nowhere close to what it should be. Get the next one here. This one is a 330 microfarad at 300 or at 16 volts. Yeah, 330 microfarad, and it reads 96 microfarads. Yeah, I'm going to say leakage looks okay. It's dropping down fairly quick. Next one is a 470 microfarads at 6.3 volts. Let's drop down to 6 volts. It's getting up there. At least this one's 364, but still, it's a 470 microfarad capacitor, and it's over 100 microfarad low. And yeah, leakage is dropping down drastically quick. So yeah, leakage is okay on that one. Now those were kind of far away. Those were on the other side of the aluminum heatsink in there. Now, next one here is 100 microfarads at 16 volts. Measures 1010 picofarads, not microfarads, picofarads. Yeah, 1010 picofarads, and it's changing a little bit. No leakage current, but yeah, it's basically open. It's got a little bit of capacitance, but it's in the picofarad range when it should be 100 microfarads. This next one, God, so hard to read. These things are burned up. It was at 10 microfarads at 16 volts. Yeah, 76 picofarads. Again, really no leakage because it's basically open. Next one is 2.2 microfarads at 16 volts. Oh, get on there, clip. Yeah, it's just open. That one doesn't measure anything. And we don't need to test all of them. I think you kind of get the idea. I will test the one good one here. So you can see it's not the analyzer that's giving erroneous results. This one's out of this, oh, for Pete's sakes. Leads are spaced so close together it's hard to get these blasted clips on. Okay, that's a 1 microfarad at 50 volt. And look at that, 0.991 microfarad. Dead nuts on, doesn't get any better than that. And leakage, nothing. So, yeah. That one, like I say, was still good. But the rest of these things, yeah, they definitely had seen better days. And like I say, if nothing else, just the color gives that away. So, best place for them, the recycle bin. So, between those, like I said, I did replace the 5 and 9 volt regulators in here. I already had everything torn apart. I already had to desolder these. It's one of those, just do it while you're there. So those got replaced. And you can see they're down in there. And I did install new modern sill pads down in there. Replaced that single sheet that they had in there. I've tested it. It transmits, receives fine. Now currently there are no channels programmed into memory. I'm going to assume the customer probably had channels programmed in, but he said it's been intermittent. There were a lot of bad solder joints on this board. The other board had a few. This one had a lot of bad connections on connectors, or bad solder joints on connectors. Some of these connectors back here, almost every single pin had broken loose. All of the bad joints around here. So, and of course, this board has the memory battery. So, if that lost connection due to one of these bad solder connections in this radio, it would have lost memory. So, I won't do it on film. I'll just end the video now. But I will program in channel memories. Put the covers back on the radio so I can really get it warmed up. Give her a test. Let it turn on for several hours. And just to make sure that it retains the memories, I'll turn the radio off and then let it sit overnight, completely cool back down, fire it back up tomorrow, do the same thing, warm the radio up, do a heavy, high duty cycle transmit testing with it, to run it through some heat cycling just to make sure all of the faults have been corrected. But yeah, I think that's pretty much all it was, just a bunch of bad solder joints. That's really all it needed. Pull the boards up, fix the bad solder joints, and replace some crappy caps. Now, he didn't say anything about that, but like I say, already had the board up. I'm not going to let something like that go, because it's just, problems waiting to happen. And honestly, this radio was probably noisy. The audio, if I had powered this radio up before doing anything to it and taken audio quality tests on it, so not just SINAD, but done like THD plus noise measurements, I'd say those measurements probably would have been rather low compared to after I'd fixed all those bad solder joints and replaced those couple caps back there, because most of those big ones, like those 470 microfarads and some of those other ones, those are filter caps for that, oops, just out of view, for that IC right there. That is the audio amplifier. So when the electrolytic capacitors that are attached to the audio amp go bad, you can start to get a lot of distortion out of that audio amplifier, because it now no longer has a good filtered, continuous DC voltage to it. It can have dips, it can have noise getting into it. So yeah, very critical to have those caps, good caps, like I say. So if anything, the audio quality has probably picked up on this radio. But yeah, anytime you see stuff like that, and that's why I don't understand. Somebody else has had this apart. Obviously, they replaced the Chernobyl resistor, which, yeah, you can see there's some white stuff there now. That's actually, I did put thermal glue in there, so that resistor is now glued to the side chassis, and replaced the wires with some good Teflon coated wire. But yeah, I don't know why anybody would ever take something apart and leave most of the problems there. Fix one or two things and just leave a bunch of other stuff that's just obviously wrong, and just leave it. I don't know. I guess I'm just too picky. So, any case, there you go. There's a Yaesu FT-840. Back in good working order. Like I say, I'll do some, won't be on video, but I'll do just some more testing with it, just to stress test it a little bit. But yeah, I think it's all fixed up now. So, there you go.